going to do the presentation on assignment 7, which is based on a multi-layer perceptron. And in this assignment, I'm going to demonstrate what I've learned and demonstrate the workflow as required by the assignment. So as you can see from my left side here, multi-layer perceptron, I already created the repo and then I clone it here. And in this assignments, I already uploaded in my code. I already have the libraries and the parameters that I'm going to use to pull up to have the output. And in this, as referring to the past assignment, we always use these libraries and the parameters to work. And in this, I have the report here, and this is the data I'm using. And in this assignment, I'm going to use 2 parameters to classify the data according to what the data that we have uploaded. I have uploaded in the to work on, and we have a classifier where I'm going to talk about accuracy, precision, recall, and the future score. And the parameter I'm using is the first one is the MLP relu Adam, and that parameter is for large data sets. And the second one, which is the LMP TAN LB FXGS, is going to be a low data set. So coming down to, let's go back to my code. Coming down to my code here, in the first place, is the requirement is to load the reprocess. The reprocess is where we are going to load the file we are going to use with the path to choose whether, because the file that we are using is Apple quality. Apple quality, we have a double condition there, the bad and good. And in this scenario, in this assignment, I'm going to create 2 pipelines to choose the bad ones and the good ones. And this pipeline, this is what I'm building it. Like I'm going to use a multi-layer perceptron for that comparison. And this is the first parameter, and giving me the first pipeline. And this pipeline, as you can see, I define the pipeline right here, and the second pipeline is also being defined here, and the plots are going to be also loaded here. And after that, the rest is just libraries and the plots. So the rest after that, now I'm coming down to, like I said, the classifier. So this is where I'm going to call the model. We'll see the accuracy, the precision, and the recall, the confusion matrix, the plots. And after that, I'm going to jump in the main function. The main function where all the argument and the data are going to pass to execute to give me the output I'm looking for. So this is the file type, Apple quality.csv file. It's already loaded, and I pass the arguments to read that data, and the data now I have to train. I think I defined a train function at some point here to where I have to, yeah, the subset data in that subset, in that subset, we have a colon for size, weight, sweetness, crunchiness, juiciness, ripeness, and acidity. These are the kind of a category of the apple we are going to look through the data set, and each of these has a number or has a data. So according to what is loaded in that data file, so my code is going to execute this and provide me the data. And I'm using also this uh, uh, this to train the model. And this is where the machine learning is coming to play to work during this assignment. So as I said it, I can just now join to, okay, also in the report I have a two plot that I can show here. And this is the first parameter. This is the first plot with the confusion matrix. And as you can see, the bad and the good, as you can see, the good and the bad and good also in according to and the predicted label. So the second one, the second parameter is giving the same, but the numbers are different. So I'm going to now execute my code to show how the code can be executed, and we will see the output. So to execute the code, I'm already in here, and let me list the file. This is the file I'm going to execute. Apple multilayer analyst.py. So I'm going to execute that code. So now, as the code is going to take a little while to execute, so let me pause the video here, and once it's executed, and then I'm going to resume to explain the rest of it before I jump on my Word document to explain the rest of the assignments. Yeah, as you can see, the code is executing. It's loaded. The script is executing. Okay, now you see it's executed successfully. So if you see, the data set that I load according to the all the binary, because all the binaries and the parameters I uploaded with the Python packages, I was able to now my code was able to execute. And you can see from the module pre-processing. And as you can see, the first matrix, this matrix, I'm going to add it to my Word document. This, as you can see, the classifier, as I show in the code, the accuracy, precision, recall, and this future score. And the first parameter, MLP review Adam, and the second one, as you can see, is a similarity. The result I'm getting here is kind of a little similar, but if you see the first parameter is 0.93, and the second one is 0.91. So just a barely similar little difference between the result. So to talk about the metrics at each level, you can see how the metrics, the output is on the at the confusion matrix level on the plot. And the second parameter also is right here, as you can see. I added all this to my document, my Word document. um as Coming back to the work document here, the main problem is to classify the good apple and the bad apple. So I use these two parameters to perform the assignment. And the first one is for large data set, as I mentioned it at the beginning, because of adaptative optimizer, that he helped to, even the huge data, he helped to scale well. And the second one, the second parameter, is for small data, and also is for accuracy. It's also for accuracy. So as you see, the algorithm of solution, this is where the software that we are using and the binary and the parameters are combined together to execute successfully. And we have the pre-process, and the download file. And coming down to the subset, I just share the screen. This is the screenshot from it. And this is where number 5, this is where I build the classifier. The classifier is the two pipeline that I built. I built this pipeline to show how we can use this pipeline to classify the data. And also, as you can see, the first one here, the second one, also second pipeline, also here to classify. And this is the output, the first output with the plots, and the second output with eight plots. So coming to analysis, we can see that the MLP Relut Adams, it had the best overall metrics. That because as it's for large data sets, he helped to work on very huge data, and we have a good output. And this was a model, we can say that we can compare this model to uh, uh, any other model. And recall, as you can see, I just put the little the one of the output score to indicate that the good work, to indicate the good balance between the false positive and the false negative when classifying the positive class. So coming to the second parameter, it had a very low value, but the difference between these two model is not a kind of it's not something dramatic, but something that indicate that this parameter is capable of learning the data, like to train the model to be able to perform the data classification. So yeah, this is the end of it. And then I just put a little conclusion to maintain the differences and the thing that how the assignment was performed, and what I gained from it, from this assignment. So thank you for watching, and I'm open to any feedback, because feedback help us to fix our mistake, and to perform well on the next assignment. Thank you.